record. Yes, we'll see what happens. I'm going to forget that I'm recording. Okay, so we're going to put all these coefficients. So 2, 7, -4, -27, -18. Now remember, when you're dividing by x minus 2, it's the solution to that factor that goes on the outside. So if you're dividing by x minus 2, it's positive 2 that goes on the outside. And since the problem says show it's a factor, that means it is a factor. That means we should get a remainder of a 0 in the end. If you don't, that means you did something wrong. So to refresh your memory on synthetic division, I drop the first number down below the bar. Then I multiply 2 and 2 together, and I put it below the next number. And then I add, and then I multiply 2 and 11 together, and then I add, and then I multiply, and I add, and I multiply, and I add. So none of this is new. But what this does, this verifies x minus 2 is a factor of f of x. Okay, so that was step number 1. Here's kind of the new thing. So at this point, we, to show x plus 3 is a factor, could do and repeat that whole thing we just did. We could set up a new synthetic division. We could put all these coefficients in it and put -3 on the outside, and we would show a remainder of 0. We could do it that way. But the next part of the problem says, then factor this thing completely. So here's what we are going to do instead. It's a skill called repeated synthetic division, which is super, super nice. All right. How many of you guys love quadratics? You love them? Yeah. How many of you, okay, maybe that's not the right question. How many of you don't mind quadratics? Is that better to say? Okay. Today, quadratics are going to be your friends. If you don't like quadratics, you will today, because quadratics are going to help you factor and solve all of these equations. The reason quadratics are so nice is because we have ways to factor quadratics. We have ways to solve any quadratics in the world. We have a formula. We can do factoring. We can do completing the square. We can do square roots. We can solve quadratics. Our goal today is this. We are going to, well, think about what just happened. We started with an x to the 4th polynomial. We divided it, and now we have an x cubed polynomial here. Okay. Our goal today is to chop these exponents down to get to quadratics. That has to be your thinking. I need to chop these exponents down to get to quadratics because we can deal with quadratics. Here's what I mean by that. This is now an x cubed polynomial. Well, I want to divide it again to get down to an x squared. Here's what this looks like. Instead of rewriting the whole polynomial, I'm just going to show x plus 3 is a factor of this new thing. Because if it's a factor of this, then that means it was a factor of the original to begin with also. So I'm just going to do another synthetic bar. And this time, I'm going to put -3 on the outside. And again, I should get a remainder of 0 when I do this. So I drop the 2 down. I multiply, I add, I multiply, add, multiply, add. Check. So I finished the first part of this problem. I just showed x minus 2 and x plus 3 are factors of the original problem. But the next thing says, now factor that thing completely. Well, here's what we know. At this point in time, here's what we know. We know now if we multiply x minus 2, x plus 3, and the thing that we ended up with down here at the bottom, which this is now a quadratic. These are the coefficients of a quadratic I would be left with. If I would multiply that thing also, 2x squared plus 5x plus 3, if I would multiply all these 3 things together, I would get back to where I started. That's what factors mean. They're things that if you multiply them, you get back to where you began. So I've almost factored that original thing. But the nice thing about quadratics is we can attempt to factor them even more. Sometimes they don't factor more, but we could try. So I want to factor that quadratic even more to factor this thing completely. This is where you guys just have to have your options in your back pocket. The AC method, guess and check, big X, slip, slide, divide, like whatever you do, this is where you employ that method. There's a number in front of x squared. I like guess and check sometimes. So I'm going to guess and check. this is like a prime candidate for guessing and checking because they're both plus signs. Like everything in here is positive. So I know they're going to be plus signs. And I know it's 2x squared. So it has to be 2x and 1x. The reason this is a prime candidate for guess and check is like the A value is prime number and the C value is prime number. You don't have a lot of options to be guessing. The only thing to guess is I need to put a 1 and a 3 here somewhere. So let's say it's a 3 and a 1. Well, the only other thing that has to be true is if you multiply the middle terms and the outer terms together and combine them, you should get back to 5x. So I get 3x and 2x. That's 5x. I know I did it right. If you guys don't like guess and check, and there's very few students that do like guessing and checking, that's fine. Just make sure you're able to do the AC method to get there. But bottom line, we started with this gross looking function. It has 5 terms, x to the 4th, bunch of negative coefficients. We would not have been able to factor that in chapter P or last chapter, but I just factored it through this repeated synthetic division process. This is the full factorization of that original problem, meaning if I multiplied all 4 of these things together, I'm not going to, but if I did, I would end up back where I started. Okay, that's the benefit of repeated synthetic division, getting to a quadratic, and then dealing with that quadratic. Okay. Now that leads into the next few examples. Okay, so what's happened in the last lesson, and in the notes and the homework, I told you what to divide by. I told you those things. I said, divide this by x plus 1. Here I said, divide this by x minus 2 and x plus 3. Like I've been spoon feeding the things to divide by. Well, that's not always going to happen. Because what happens now in example 1 says, find all the zeros of this function. Now, let me explain that question. Anytime a problem says, find the zeros, or if it says like, find the solutions, or it could say, find the roots, it could say find the x-intercepts. Those all mean the same exact thing. It basically means figure out what you would plug in for x that makes this function equal 0. That's what it means to find a 0. It's figuring out what would you plug in for x that would solve this equation and make it equal 0. Okay. And this is what your whole last chapter was about. Solving equations was the entire last chapter. In last chapter, everything I gave you could be factored. Now they can't. We can't factor this thing. Our goal is to chop this thing down to a quadratic. And here's what that means. If I'm dealing with an x to the 4th equation, then I need to find 2 nice things to divide by with synthetic division to chop it down to a quadratic. I got to find 2 nice things to divide by. They're not given to me. And the way we find those things is our calculator. There's no thinking. Our calculator is going to tell us the things to divide by. So instead of me telling you what to divide by, now I don't, but your calculator will instead. So what we're going to do is this. You're going to take out your calculator. You guys at home too, I would practice with this. And we are going to graph this original equation. That's step number 1. I want you to graph y equals that x to the 4th equation. And there's no way to do this problem without graphing these equations. So we're going to graph y equals x to the 4th. And if you guys need a refresher on graphing, let me know. And I'll show what my graph looks like so you can make sure that you graphed it correctly. So I'll wait for a second until we're all on the same page. Does anybody's graph not look like this?
Can you show us how to get to that again?
The y equals screen or the graph?
The y equals screen.
So in the very top left button, anytime you want to graph something, you'll push this y equals right here in the top left. And then you'll enter your equation here in y1. And then when you want to actually see the graph, the very top right button says graph. Let me know if you get there. Everyone good? No error messages, no weird windows, things like that? Okay. So last class, this came up within the notes, the very first example, we did a long division problem, and I said, all you need to know is how to divide. But then I talked a little bit more about the problem, and I said, you know, we can factor, we can find solutions and things like that. And then we graphed it, and I had you guys see where those solutions show up. The solutions to any equation in the world are the x-intercepts of the graph. So what we're after are the x-intercepts of this graph right here. That's what I want to find, are those x-intercepts. Ms. Barr, if you had to guess what the x-intercepts are of this graph, what would you guess them to be? -1 and 2, right? And you're probably correct. But it could be like this could be crossing at like 2.01, right? We don't know exactly. So here's what our calculator is going to do for us. Instead of just looking and eyeballing it, we are going to have our calculator tell us exactly what those x-intercepts are. And this is the new skill in your calculator we have to know. My calculus kids just took a test, and they had to use this skill on several problems on the test. They had to solve some like gross equations, and they had to graph them and find the x-intercepts. So here's how we do it. When we want to find x-intercepts, in the top row, right above trace here, in blue, it says calculate. Anytime we want to calculate something from the graph, we're going to go to this blue menu right here where it says calculate. I'm going to kind of go through this slowly, but I want you guys to practice this in your calculator too. So I push second, calculate. Now we're after the x-intercept, but in math speak, that means 0. So we're trying to find the 0, the x-intercept. So we go to option 2 and we push enter. Well, let me explain what we do from here. Let's say we just want to find this left x-intercept that looks like it's at -1. The calculator says left bound with the question mark. What it wants you to do is take your cursor and arrow until you get left of that x-intercept. Just arrow to the left until you're a little left of that x-intercept. That's what left bound means. It means go to the left of it. And then you push enter. And then it says right bound. Well, then you arrow to the right of it. So arrow to the right. And then you push enter. And then your calculator says, would you like me to guess? It's not really guessing, but it's running a lot of calculations in the background. I don't actually know what it's doing, but we just push enter again. And you were right. It is -1. The reason it's important to know this skill is because your graph might not always be crossing at whole numbers or integers. It might be crossing at 3/4 or something where we can't eyeball it. And so this is a feature we're going to have to know how to use. Let me explain what this means. I said at the very beginning, we need, if we start with an x to the 4th equation, then you need to find 2 nice numbers to divide by to get it down to a quadratic. Because if you have an x to the 4th equation, how many solutions might you have to this equation? You might have 4. Okay. Well, we can see 2 of them right here. But what if there's 2 more, and we're going to have to find those somehow? And the way we find those, we're going to start with synthetic division, and we're going to use -1 to chop this down at least to an x cubed. That's how we're going to start. So we're going to do synthetic division. I'm going to put all these coefficients in the top. And since -1 is the solution, -1 is the number that goes outside. The solutions go outside the synthetic. So I put -1 on the outside. And I should get a remainder of 0. And I do. So I've chopped this down to an x cubed equation. Now that means I need one more number to divide by, and it looks like 2. Let's just verify for practice sakes. Another option you could do, let's say you're pretty sure it's 2, like a whole number. You're like, I'm almost positive, and you want to kind of skip the calculate process. You could go to your table right here above graph. If you go to your table and you put in 2, if the y value is 0, then that is your x-intercept. So if you're like, I'm almost positive it's that, and you just go in your table and check, then that's an option. like I said, sometimes it's not going to be crossing at whole numbers and you're not exactly sure. So it's important to know how to use that calculate feature. So it is 2. And so that means I'm going to do a repeated synthetic division and put 2 on the outside. And this is going to get it down to a quadratic. And then you'll see what we do from there. Bring the 1 down, multiply, add, multiply, add, multiply, add. And then I'll wait, make sure we're all on the same page. All right, so this problem initially said, find all the zeros. I found 2 of them. -1 is an answer, 2 is an answer. But what happens now is I'm left with a quadratic. These are the coefficients of a new quadratic equation. So there's no x term. It's x squared plus 3. And the way I get the other 2 answers, I solve this quadratic equation. This is why quadratics are your friend, because we can solve every quadratic equation in the world, whether it's through factoring or the quadratic formula or whatever the case may be. We can solve every quadratic equation in the world. That's why we're trying to chop it down to get to a quadratic, and then we solve this quadratic. And this takes us back to last chapter of solving this thing. I would subtract 3. And then I would square root both sides. And remember, anytime you square root, you have to put plus or minus. That's where your other 2 answers come from, right? We're trying to find 2 more. That's the positive and the negative. Bless you. When you square root a negative, you get an I on the outside, and it still says square root of 3. That's also why, hang on real quick, I'll answer your question. That's also why when we graphed it, it was only crossing the x-axis twice. Anytime you have imaginary answers, you'll never see those show up on your graph anywhere. So just because the graph is only crossing the x-axis twice, that doesn't mean there's only 2 answers. You could have imaginary. Yeah. Should always be outside. Can't think of a case where the I is under the radical. Never seen it. I guess if you were like square rooting the square root of -1, you would then have the square root of I. Yeah, what's up?
Can you show me how you got
to in the table?
Yeah.
Yeah, so and this came up, man, quite a while ago, but I would double check this feature on your calculator if let me explain. So go to your table. It's right above graph in the right here. It's in blue. It says table. This is a really important feature of the calculator as well. So if you push second and then table. Now, do any of you have, is your calculator set where it just generates all the numbers? Okay, I would change that. I would change that setting, and I'm gonna tell you why. When you get up to higher level math, you might want to find the Y value when X is 10,005, when you're getting into like big dollar amounts, and you don't want your table, you don't want to have to scroll down until it gets to 10,000. You should want to be able to just put in 10,000 and see the corresponding Y value. You want to be able to put in your own X values. That's how I have my calculator set. So if I were you, I would change the setting, and here's how I would do that. And I would always have this setting. So right above window in the top row, it says table settings in blue. So I would push second and then table settings. And I would change my independent variable, which is the X value, to ask instead of auto. And then that way you can always pump in any X values that you ever want to see the outputs for in your calculator. And that would also be like, let's say you wanted to find the Y value when X is like 2.5. Well, with your setting, you wouldn't be able to see it. It's only showing you integers. This way you can put in 2.5 really quickly and see the output. Yeah. Probably because in my table, oh, I actually don't know. I thought maybe I had 4 in there. I don't know. Well, the table start won't even matter since I changed this to ask. It would only matter if it was auto. Like if I change it back to auto, I bet my table will start at 4. Yeah.
All right.
And so we have 4 answers to this equation. I would list all 4. I'll have people on a test. They'll do everything right. And then on the answer blank, they'll only list these 2 things as the answers. Well, these 2 things we found initially are answers. We use them to find the other answers. We still need to list them. There's our 4 answers to that equation. Thank you, graphing calculator. Could not have done it without you. Questions on our process. That's kind of the process today. We graph, we find nice numbers to do synthetic with, we chop it down to a quadratic, we solve the quadratic. I mean, that's what it is. Someone, I don't know if it was last block or yesterday, they said, well, what would happen if I graphed this and I didn't get 2 nice numbers to divide by? I couldn't do that to you. We wouldn't be able to solve if that was the case. So it's going to happen. You're going to have enough to chop it down to a quadratic. So let's look at 2. Find all the zeros of this equation. Well, we're going to start by graphing this equation. We're going to graph it. Someone last block asked a really good question. They said, couldn't I try to do factor by grouping on this one? And I looked at it, and it actually does work. Like, you could do factor by grouping to solve this. We're going to practice this technique because let's say factor by grouping didn't work. We have to know how to do this, but it does work. I thought it was a really good lookout for them. So we're going to go ahead and we're going to graph this equation. I'm going to set it equal to 0. I'm going to graph. I'm going to graph you cubic equation. There's nothing you could do about it. So here's the graph. Make sure we're all on the same page with the graph before I explain this one. We're doing 3 of these. Each one has just like a little bit of a different wrinkle to it. Okay. But I want to make sure we at least graphed it all correctly. All right. So on this one, you know, if I had to guess where it was crossing, it's not crossing out whole numbers on this one. What I said on the previous problem, and now I'll explain what I mean by it. On the previous problem, I said we need 2 nice numbers to divide by. And at that point, you didn't know what I meant by nice. I'm explaining what I mean by nice on this problem, okay? So we need 2 nice numbers to divide by. So I want us to find that first x-intercept. I want us to calculate that most left x-intercept, and let's see what it looks like, okay? So if I want to find this most left x-intercept right here, I push second, calculate, and I want to find the x-intercept, so the 0. And then I want to arrow. Now here's the thing when you're like doing your cursor, sometimes you'll start to arrow and it'll disappear from your screen, and students are like, well, I don't know where it is now. Well, down at the bottom of the screen, it shows you where your cursor is in the coordinate plane. Like right now, mine is at -0.2, 15. And my calculator only goes up to 10. So it's like up here somewhere. I don't know. That doesn't even matter though. That just gives me an idea of where it is. But I'm just going to keep scrolling left. So what's happening is it's going up here, and then it's going to start to come back down when I keep arrowing to the left. See, now it's coming down. My y values are getting smaller. Now there it is. So if ever you lose it and you're like, you don't know where it is, just focus down at the bottom and you can see where it is. And that'll help you find it. But I want to get left of that x-intercept. Someone last class said, I don't know what you mean by left. Well, it means less than. So like, if this x-intercept looks to be at like -2.1 right here, I want my cursor to be less than that, like -2.3. That's what left means, is less than. Then I push enter, and then I arrow to the right, right bound, push enter. It says guess. I say yes, please. Now let me explain what this number is. This is the wrinkle on this problem. I've said you need nice numbers to divide by. Well, my first question is for this one, how many nice numbers do I need to get to do this problem? Would you have to get? How many do you have to divide by to get it to a quadratic? Huh? Not 2, just 1. If I had one nice number to divide this by, I would divide it, and that would get me to a quadratic, and then I own the world because I can solve that quadratic through any means that I want to. I need one nice number. Now, when I say nice, my first question is, does this look like a nice number to be using? No, it's not. What I mean by nice, I mean rational. Like 0.5 is a nice number. 0.75 is a nice number. 0.3 repeating would be fine. That's 1/3. Any number that you can put into as a fraction is a nice number. What this means this x-intercept right here is an irrational answer. Like it's the square root of some non-perfect square. What it means is I'm not going to use it in my division. Okay? I'm going to find it eventually. I'm going to find it exactly what it is, but I'm not going to use it in my division. So that kind of sucks. I found that. I'm like, okay, I'll find you later. Let's move on. Find a different one. Okay. So let's say I want to find this middle x-intercept. I want to find the middle one right here. Okay. Well, I'm going to do second, calculate. I'm going to do 0. And now I want to find that middle x-intercept. So I'm going to arrow to the right. Keep arrowing until you see your cursor. There it is. Notice this time the left bound, it doesn't mean above or below the x-axis. It means left or right of that x-intercept. So notice on this one, my left bound is here because that cursor is left of that x-intercept. I push enter. Go to the right. Push enter. Yes? Yes, please. It says 0.4. That's a nice one. That's the one we're going to use because that's 2/5. That's a fraction. So what that means is I'm going to take this cubic equation and I'm going to do synthetic division with 2/5 or 0.4. It doesn't matter which one you do. I like fractions better than decimals, so I'll do 2/5. And we should get 0 as a remainder. Bring the 5 down, multiply, add, and multiply. 2/5 times -25 is -50/5, so -10. Aha! It worked. I did it. Now I've chopped it down to a quadratic, which is the whole goal, because now I can set up this new quadratic equation. So this is 5x squared, no x term, minus 25 equals 0. And when I solve this quadratic, I'm going to get those other two answers. How do I know, before maybe you know or don't know, how do I know there's not going to be any imaginary answers in this problem? Yeah. Well, that is why, yes. But from the get-go, I should have asked at the beginning. How could I have looked at this graph and known there weren't going to be any imaginary answers at the beginning? I could have known right away. Been like, saw it, no imaginary answers. Yeah.
It's a cubic equation and there's 3 x-intercepts.
Yeah. This right here tells us there's at most 3 answers. And if I see it crossing the x-axis 3 times, that means they're all real solutions. That means there aren't any imaginary answers. You don't have to know that, but that does start to help kind of make sense of how many solutions and imaginary and real solutions and things like that. So I'm going to solve this. I'm going to add 25. Divide by 5. Don't square root yet. Get rid of that 5 first. And then square root. Plus or minus. Don't forget plus or minus. So the other decimals that we found, the like 2.23 and -2.23, those were the square root of 5. We wouldn't have known what they were without going through this process. So my answers are 2/5 and then plus or minus the square root of 5. What do you guys think? you think, Mr. Decker? What do you think of these?
I don't understand why you could, it would, when you use 5x, instead of 5x.
Yeah, so go back to the first problem here. When you're doing synthetic division, what's happening is, like, I'm taking an x to the fourth polynomial at the beginning, and I'm dividing it by an x to the first polynomial. And when you do an x to the fourth divided by an x to the first, basically when you do synthetic division one time, the result is going to be an x cubed polynomial. Like x to the fourth divided by x to the first is x cubed. Then when you take that x cubed equation and you divide it by x again, now you're left with an x squared equation. So when you're doing synthetic division, you're taking whatever exponent you started with, and after you do a division, now the result is one less than that. I'm gonna have you guys try the next one. Try example 3. It has its own little wrinkle. We'll see how far you get. You guys at home too. Sweet dog, whoever that is. Someone's got a picture of their dog. Doesn't let me see who's who when I scroll over. Oh, Sydney. There it goes. I like your dog, Sydney. I would start by graphing it. Oh, the weather outside is frightful. The fire is so delightful. Since there's no place to go, let it snow, let it snow, let it snow. Curious if anyone gets there, figures out what the little trick is on this one. My hope is that we all got at least to here, that we could get to here. Sorry if I spoiled it for you. I'm gonna kind of walk through this one. It's a little bit different. So here's the graph. And then how many of you found this most left x-intercept, and it was some gross number? I don't know what it is. Found it, so it can't be used. And if you would look at the most right x-intercept, it's also some gross number, can't be used. And I've said, and I haven't lied to you whatsoever, but I've said, if you start with an x to the fourth equation, you have to be given or be able to find two nice numbers to divide by to get it to a quadratic. And I have not lied, okay? That means there has to be one more number we can divide by to get this to be a quadratic. Let me know what that number is. Say it. It's 1. We do it again. This is called the bounce effect that you might see happen sometimes, okay? This is kind of the new thing on this one. If ever your graph hits the x-axis and like bounces off of it, like reflects off it, like it's a wall, then that is a repeated solution, a number that you can use more than once in your synthetic division. Now, I'll explain what it means here in a second, but in general, notice how this graph hits at 1, goes ding, and bounces off of it right there. That means you have a repeated solution that you can use. You can use 1 again in synthetic division. I've said that this number, this leading power, tells you the maximum number of solutions you can have. While that's true, it actually does tell you the number of solutions that you have. It's just sometimes you get the same solution multiple times. Like 1 is a solution, and then 1 is also a solution again. So in this problem, there's going to be 3 answers, but we only have to list one time. Like we wouldn't say x equals 1. Oh, but wait, x equals 1. Like you wouldn't list it twice. What happens is this, and why you might get something like that. If you factored something, I want you guys to look at this before you start working. If I gave you some function and we factored it, okay? And let's say it factored into this thing right here. And I said, hey guys, what are the solutions to that equation that you started with? What would the solutions of that original equation be if I factored it and got this? What would the answers be? Mr. Ringo, what would the answers be if these were the factors? 2 and -1, right? There's only 2 answers. You only list 2 one time, but it's because that factor showed up multiple times. That's what that means, is when you get a repeated answer, that just means its factor was a part of that thing like multiple times. That's what's happening. All you really need to know is that that's a possibility, and it happens when it bounces off the x-axis like that. So we're going to use 1 again to get this down to our quadratic. So we chopped it down, we divided again. This is now a quadratic, x squared minus 7. We're going to set that equal to 0, and we're going to solve this to get those other answers that were some irrational number. So add 7, square root. We get plus or minus square root of 7. Don't forget plus or minus. When we list the answers, again, you don't have to list the 1 twice. You just say x equals 1 and plus or minus square root of 7. Those are the answers to this equation. All right, the last thing. We're going to skip example 3, first of all. We're not going to do that, if that's okay with you guys. We're going to skip example 3. We are going to do example 4. Before I do example 4, though, I want to talk about one thing that doesn't matter in terms of you guys solving things, but just something that happens. So I don't know if you've noticed, but all the times that we got imaginary answers, or if we got irrational answers, there was always a plus or minus with it. And that's because of this thing right here. If ever you have irrational or imaginary solutions, they will always show up as conjugate pairs together, always. What that means is if you're going to solve and you know that 3 plus 2i is a solution, then you automatically know 3 minus 2i is also a solution. They always come hand in hand. That will never not happen. Never not happen. That will always happen. That's better. Same thing goes with the irrational answers. If you know 6 minus the square root of 2 is an answer, then 100% 6 plus square root of 2 also has to be an answer. I do have students that will know that, and then they get tricked, not tricked, but they'll actually think, well, that means if 5 is an answer, then -5 is an answer. And that's not true. This is only for imaginary and irrational numbers. Okay. But the very last problem, and then you guys at home are going to be able to hop off. Up till now, I've given you the equations, and we had to find the answers. Well, now I'm giving you the answers, and we have to go backwards and find the equation. Those are the answers too. So this one says, find a polynomial function given the following solution, 6, 2i, and -2i. I want to go backwards and figure out what was the original equation that if I solved it, I would get these three answers. Any guesses? Yeah.
You do x plus 6 times x plus 2y times x minus 2y.
You are about as close as you could be without being correct. And I think when I show you this, you'll see your mistake. Back on example 1, if 2 is an answer, what was the factor that went with 2?
Oh,
Yeah.
Yeah.
Yeah, so what he said initially, he said, wouldn't you just write x plus 6, x plus 2i, and x minus 2i, and then multiply them together? He's spot on. The only wrong thing with that is if you know something is a solution, like going back to this one, like if you know 2 is a solution, then that means x minus 2 was a factor of the equation. So and if you know that -3 is a solution, then you know x plus 3 would be a factor of whatever the equation was. So we need to turn our solutions into their corresponding factors and then multiply it all out. So our function would have been y equals, and then we know if 6 is an answer, it's always minus, then x minus 6 was a factor. If 2i is a solution, then x minus 2i is a factor. And if -2i is a solution, then x minus -2i is a factor, but we just write x plus 2i. And then we just multiply these three things together in any way you want to. I would multiply these two together because when you multiply these two, the i's will go away. So I'm going to FOIL that out. So x squared. The outer terms would be 2xi, and the inner terms would be -2xi. So those cancel. You don't even need to write them. And then -2i times +2i. Well, that's -4i squared. So +4. And then we just multiply these two things together. So x cubed plus 4x minus 6x squared minus 24. I would put that in order just because it looks much nicer on the eyes. So that's the original equation that if I would solve that equation, I would end up getting those three solutions. Take your solutions, put them as factors, multiply it out. That's it. That is all of first semester Honors Algebra 2, COVID style. There were a few things that we didn't do. Make sense? So we don't have a quiz or a test on these. There's a few on your final. Your final right now is, I think, 20 questions. I think 2 or 3 revolve around this. You'll have to do long division. There'll be a problem where you have to graph and do repeated synthetic. So probably 2. Yeah. I don't think so. Have you worked ahead?
I work on
Yeah, there shouldn't be, but I'll look here in a second just in case there are. Because say that. What's up?
Are we gonna have to know how to do long division and synthetic?
Yes. So there is going to be a problem on your final that, I mean, I don't mind telling you guys this, where it says like use long division to divide. I don't remember what it is. I'm just completely winging it. Where it says like do long division to do this thing divided by this thing. And you have to do long division if you're dividing by x squared or x cubed or whatever. So yeah, you will have to do long division one time on your final. So on your final, I'm going to let you guys have a cheat sheet, a half sheet, which for you guys, I'm going to pass that out to you guys now. It's this pink sheet here. If you guys at home are wanting to work on this in the next few days, feel free to just fold a piece of paper in half, cut it, and you can work on it. But if you want to wait until Thursday, when I see you guys in class, I'll just pass the pink sheet out to you then. But That way you're not at a disadvantage if you're wanting to work on this in the next couple of days. So aside from that, your extra credit is due at 4, and you guys are free to go. It's been a wonderful, wonderful class. I need to pause the Zoom before I forget. Stop recording.